Okay. So the molar ratio notes. Now I've given you guys the notes with everything filled out in them already for the most part. I'm just gonna highlight a few things and write a few small things in there. So, okay, molar ratio. The molar ratio is a ratio of moles of substances, reactants and products, in a balanced chemical equation created using coefficients. So, like I told the other class, bad news, good news. Which one do you want first? Bad news or good news? Bad news. Okay. The bad news is you don't get to forget everything that you learned last unit. You need to use it all in this unit. The good news is if you know what you were doing last unit, there's not a whole heck of a lot of new stuff, brand new stuff in this unit. This unit actually will be a lot easier. Okay. If you didn't, then you'll need to catch up some, but there's not a ton of actual new stuff. This is more actually taking some new stuff, some of the stuff from last unit and kind of using them together. Okay. So you'll see a lot of familiar things in here, like this. 1 mole of any substance equals 6.02 times 10 to the 23rd particles. So remember, particle label could be, that's the category, right? It could be, just blue so you can see the difference. So it could be atoms, formula units, or molecules for the label, right? For the particle label. So we already know that. Now, so in the equation, 2H2 plus O2 yields 2H2O. This indicates a ratio. If we were to look at this and say, what is this saying? It'd be 2 molecules of hydrogen plus 1 molecule of oxygen gives us 2 molecules of water, right? All right, so then look at the math here. And like I said, this is already done for us. So if we were to take 2 molecules of hydrogen and 1 molecule of oxygen, and we were to turn those into moles, like you did last unit. So 6.02 times 10 to the 23rd molecules equal to 1 mole, right? We get these numbers of moles. This amount of moles of hydrogen, this amount of moles of oxygen. Make sense so far for everybody? Okay. If you express that as a ratio of moles of hydrogen to moles of oxygen, you get this. Put the moles of hydrogen over the moles of oxygen, we get 2 over 1 if we divide it. Okay. Notice, this is the same as the ratio of molecules that we started with, which makes sense mathematically because we had 2 over 1. We divided both of them by the exact same number, right? So think about imagine if you had a ratio of 2 to 1 and you multiplied both of them by 10. What would you get? You get 20 to 10, right? Which is still the 2 to 1 ratio. So it's the same. Okay. So 2 to 1. Now, you don't have to redo all of this. This is the mathematical explanation behind why we can say this. This shows us there is no need to convert from particles in order to get a ratio of the moles in the equation. We can just get the molar ratio by using the coefficients in the balanced chemical equation. In other words, we don't have to go through all this craziness here in order to know that the coefficients in the equation represent the number of moles. Okay, so for this equation, 2H2 plus O2 yields 2H2O. That means we have 2 moles of hydrogen for every 1 mole of oxygen, and they're producing 2 moles of water. So the coefficients are the number of moles. Okay. You're heading back. And you double check to make sure you had labels on stuff. Thanks. Okay, so that's the molar ratio. So the first problem here, and it's already done for us, but the other good thing about these are, this is why I like hammer dimensional analysis over and over and over, because you're using the same thing. Okay, different labels, but the same idea. So you start with what you're given. 3.18 moles of O2. We're turning it, they want to know how many moles of water that is. So moles of O2 on the top, moles of O2 on the bottom. We're turning it into moles of H2O. Now, where do these numbers come from? Anybody know? These are the coefficients from the balanced equation. Okay, so if you look, what's in front of H2O in the balanced equation? The 2. Right? So that's where the 2 there comes from. If we look, what's in front of the O2? Well, in front of O2, there's nothing, which is 1. Does that make sense? All right. Now, when you're writing these down, and doing these problems, you must show work. Now, I know these are really easy. Like, you could probably look at them and be like, oh, well, they're really easy. It's coefficients, either divide or multiply. Yes. You must show all the work. And that includes putting in the full label, both parts of the label, and setting them up like this. Okay, there's a couple of reasons. One, putting the full labels in keeps you organized and makes sure that you're doing the right thing, either dividing or multiplying or whatever. Secondly, when we go into the stuff tomorrow and the next day, the stoichiometry stuff, we're going to use this molar conversion idea as part of a longer conversion. As part of a multi-step conversion, it's only one part. And if you don't put in your labels, you're going to be super confused about where you're at, what you're starting with, where you're going. Okay? You must put in the label. Both parts of the label. The label has 2 parts. It has the part that tells us what we're measuring, like moles or grams or whatever. And then it has the substance part, which tells us the substance we're talking about. Here's why you have to have both parts. In last unit, we were always only talking about one substance. We're going from like molecules of aluminum to grams of aluminum or whatever. Here we're talking about 2 different substances. So if you ignored the substance part like this, well, look at your labels. It's just moles to moles. That wouldn't make any sense. How do you know what numbers to put in for? You don't. That's why you have to have both parts of the label. Okay, the moles and the substance. Because here we're actually changing substances in this unit. Okay? Questions? All right. So I'm going to pause this for a second. Okay. So we're going to do number 1, go back to number 1 and actually work through that one. Okay. So it says lead will react with hydrochloric acid. So we got that. That's our balanced equation. How many moles of hydrochloric acid are needed to completely react with 0.36 moles of lead? So just like all the other conversions we've done, you start with what they give you. Okay, now you might want to start it a little bit. I'm going to start a little bit further here on the left so I make sure I have enough room for the other ones. But and by the way, if you write big or don't want to, if you feel like you're cramming everything in, you want to do it on another sheet of paper, you can totally do that. It's fine. But start with the 0.36 moles of lead. So 0.36, and we need both parts of our label, the mole and the substance, lead, Pb, like this. We start with that. Okay, now, the nice thing about this is it's just like all the other dimensional analysis in terms of putting our labels where they go. So we're trying to get it out of moles of lead, right? We're trying to get rid of that. So if that's up here, our label moles of PB is going to go on the bottom, so we can cancel. Now, ask yourself, what are we turning this into? Well, how many moles of hydrochloric acid? That's what we're looking for. So that's what we're going to put on the top. Moles of hydrochloric acid, HCl. Now, it's worth it here to pause for a second and me to show you something. So sometimes people get confused because like this is like, well, lead's on the left side of the equation and so is HCl. It does, I mean, it matters when you're making the equation, but in terms of doing the conversion, the nice thing is it doesn't matter if it's on the reactant side of the product. If you know one of these things, you can figure out any of the other ones. So it could be like right now we're going reactant to reactant. It could be reactant to one of the ones on the product. You could start with one of the ones on the product and go to the reactant. You could have a product to a product. It doesn't matter. If you have any one of these, you can figure out the other ones. Okay? So we've got moles of PB to moles of HCl, right? Anybody remember where we get the numbers in front of those? Excellent, the coefficient. So we look in front of HCl. What's in front of that? 2. So we go 2. We look in front of PB. There's nothing, so that's a 1. Okay, now, if we look at this, right, moles of PB would cancel. Left with this, which is what we want, moles of HCl. And we just multiply by anything on the top, divide by anything on the bottom. So 0.36 times 2. Now, significant figures, the same as all of our other conversions. You look at the beginning number only, however many that has, that's how many your answer needs. So our beginning number is 2. We have 2. So our answer needs 2. Now, luckily, it's already 2. It's 0.72. But if it was more, you'd round to two significant figures. And our label we're left with, you got to have both parts. Moles, HCl, both parts of the label. So this is exactly what I want in terms of work. Okay? Work and answer. All right.